That's why in this video, we are breaking down the fundamentals that really matter. Pipes that are at least 3 mm thick, strong shroud stay stable. What if someone's 1.50 m or 2 m stem? Ever had a machine break right when you need it most, or watch a client walk away because something just didn't feel right? If you manage a gym or supply equipment to one, you know how one weak link can mess up the whole experience. And you also know it's not just about shiny logos or big brand names. It's about one thing: reliable quality day in, day out. What holds up your gym is what's holding up your business. That's why in this video, we are breaking down the fundamentals that really matter. Not the fancy features, not the flashy finishes, just what works and what breaks. Let's get started. Worried your machines won't hold up under pressure? Start with steel. Let's talk about the basics. Steel. For commercial-grade machines, you want pipes that are at least 3 mm thick. Not after paint. We are talking raw steel, measured before any powder coat goes on. Take a look at this. 3.4 mm solid stuff. That kind of thickness is what gives a machine real backbone. Now here's the catch. Most machines out there use 2.5 mm or even less. But strength isn't just about how thick the pipe looks. It's about section modulus and moment of inertia. Basically, how much the pipe resists bending and holds shape under pressure. When you go from 2.5 to 3 mm, the moment of inertia increases about 13%. That means better resistance to flexing, twisting, the stuff that makes machines feel solid under load and under stress. Whilst on thinner pipes, like 2.5 mm, are up to 50% more likely to tear. Especially over time, with repeated heavy use, 3 mm steel just gives you more room for error and more room for safety. It absorbs more impact, reduces structural fatigue, and holds up even if the weld isn't perfect. Now, some brands do use 2.5 mm, and that can work, but only if every single part of the build is flawless. If not, it becomes a long-term weak point. Here's something most people miss. See this band? It's not welded, it's band formed. When you bend the tube instead of cutting and welding it, you keep the structure continuous. No sinks, no stress fractures, no weak points. For machines that take impact every day, that kind of structural integrity makes a big difference. We mainly use band-performing, well-strength machines most, and only cut where absolutely necessary. It takes more time, more labor, but in the long run, it gives peace of mind and better performance. Now, let's see how this kind of build holds up in action. Watch the machine, watch the movement. No shake, no flex, just a solid control. Ever put a cable and feel to jerk, rattle, or catch halfway? That's not just annoying, it breaks rhythm, trust, and the whole training flow. Whenever you pull a cable and it feels smooth and steady, that's not just design, that's material and precision. Good machines use PLM for their cams and pulleys. It's not metal, it's not cheap plastic. It's a dense, self-lubricating polymer. Strong like metal, but runs proud like plastic. Then comes precision. CNC machining ensures pulleys are perfectly round, balanced, and uniform in resistance. That's how you get a flow, not friction. Watch this. I pull the cable, and even at the slowest speed, there's no catch, no noise, no bounce. And it's not just the outer shell. Inside the pulley, smart systems use a solid bearing core with extended bushings on both sides. That locks the axis in place, reduces side friction, and prevents long-term drift. This keeps motion smooth, rep after rep, even under daily heavy use. When done right, you don't notice a pulley at all, because it works perfectly. But when it's not, you feel the wobble, hear the rattle, and lose the confidence. That's why material and machining matter, because the performance should feel right from the first rep to 1,000th. Have you ever seen a seat sink, crack, or start peeling after just a few months? It's not just a comfort issue, it's a design flaw, and it starts inside the seat. Let's start with the foam. What matters is density. Good seats use a high-density foam between 57 and 67 kilograms per cubic meter. That means when you press it, it pushes back. No sagging, no soft spots, just a solid support. Then there's the cover. Commercial-grade PVC leather is what holds up in real jeans. It resists weight, friction, and cracking, and wipes clean in seconds. Watch this. Just a little water, a quick wipe, and it's ready. That's what low maintenance should look like. Now go deeper. Underneath the foam, a strong seat doesn't rely on wood or scrap metal. It uses molded PP, a one-piece industrial-grade plastic base. That means no loose edges, no warping, no cracking when someone shifts their weight. If you see gaps, bulgy corners, or peeling leather, that's not just wear and tear. That's a seat just wasn't built to last. In a commercial gym, details like this makes the difference between daily trust and daily repairs. Ever had a frame crack while it's still under warranty? That's more than bad luck, it's a bad structure. And in the gym, nothing is more important than the frame holding everything together. Some manufacturers offer 5 years, some stretch it to 10. But what it will take to confidently promise a lifetime warranty on the main frame? A lifetime warranty isn't just a promise, it's a result of structural engineering done right, not marketing mechanics. A frame like this, it's not just strong, it's strong enough to take daily use, real stress, and still stay solid for years. Because when it comes to heavy-duty equipment, a frame warranty is only good as what's holding up. Ever had a machine that looks fine but still shakes during use? It's often not the pipe, not the paint, it's the connection point, the joints. When we talk about strong frames, we often forget it. It's not just the tubes, it's how they're joined. Low-cost machines may use just a few surface welds or thin connector plates. That's easy to assemble, but it's also where failure starts. Under load, those weak joints start to crack, shift, or worse, separate. That's why reinforced connections matter. Flange plates, locking bolts, oversized washers. These aren't overkill, they are what distribute force, anchor the frame, and keep it steady. It takes more time to build like this, almost twice as long in some cases. But the result? The structure stays strong for years, not months. Every time someone presses, pulls, shifts, it's a joint that absorbs the stress. And when it's done right, you don't feel it, you just feel solid. Because in heavy-use environments, strength isn't just in the steel, it's in the smallest details. Have you ever seen gym machines look all the way before they are? Chipped paint, rust spots, sticky surfaces. That's not just wear, that's weak surface treatment. The frame may be strong, but the finish is what people touch. And what is sweat, humidity, and a daily clean touch too. That's why good machines use a high bond powder coating. It resists scratches, won't peel or flake, and keeps a smooth, clean feel. It's not just about how it looks, it's about rust prevention, surface integrity, and easy upkeep, long term. Want a quick test? Take a key, give it a scratch. If the finish holds no flakes, no exposed steel, that's a surface that's built to last. Because in commercial gyms, a surface that holds up keeps everything else looking and performing better longer. Ever had a cable snap mid-wrap? It's not just frustrating, it's dangerous. And in a commercial gym, one cable failure can cost away more than a replacement part. A machine's performance lives or dies by the cables. Strong cables aren't just about pulling weight. They need to handle hundreds of reps every day without stretching, fraying, or cracking. Not all cables meet that standard. Too thin, they stretch. chip coating, they peel, slip, or dry out. That's why high-performance machines use steel core cables at least 3 millimeters thick, tightly bonded coating, often TPU, that fuses to the core, not just slides over it. Here's a benchmark: 300 kilograms of constant load, held over 24 hours. No stretch, no stack, no structural fatigue. Because performance isn't about how it looks, it's how it holds up when it matters. Pour after pour, the tension stays smooth. That's what gives users confidence and owners peace of mind. Reliable cables aren't just the components, they're the heartbeat of the whole system. Most injuries don't come from heavy weights, they come from overlooked design. In commercial gyms, not every user is an expert. That's why real safety isn't just one feature, it's built into everything. Let's start with the edges. No sharp corners, no exposed seams, just smooth curves, so even accidental contact stays safe. Then there are moving parts, weight stacks, cable, pulleys. They need to be fully covered. Why? To keep hands, fingers, and clothing out of danger. Not just better looking, better protected. Now think, what happens if someone falls a rep middle set? Without safety stops or shock absorption, that weight slams down. But smart systems include limit blocks, shock absorbers, and end-of-range stoppers. They catch the job when the user can't. Even foot plates matter: non-slip surface, stable grip, small details, yes, but it's often what prevents slips, stumbles, or worse. Because safety isn't just about compliance, it's about confidence for every user, every rep. Ever had a machine fail, not from the frame, but from a loose bolt or cracked trim? It's the small stuff that often causes the biggest problems. Let's take a closer look. Start with the hardware. High-quality machines use fasteners rated 8.8 or above, engineered for high torque and lasting tension. No loosening, no wobble over time. Next, the bearings. Well-built pulley systems rely on sealed ball bearings, stable axis alignment, consistent low-friction rotation. This reduces noise, protects from dust and sweat, and keeps motion smooth over years of use, not just during showroom demos. And even the shroud matter. What you want to look for: thick wall construction, impact resistance, anti-warp design. When covers flake or crack easily, it's a sign of poor material density. Strong shroud stays stable, even when stepped on or bumped repeatedly. Decorative trims aren't just aesthetic, they face scratches, contact, and foot pressure. So the smart way? Make them thick, dense, durable. You can feel the difference when you hold one. Here's a simple test. Tap it. If it feels hollow, light, or rings like plastic, that's a warning. Looks can deceive, and we have seen aluminum parts that cracked under use because they weren't aluminum at all, just plastic, painted to look the part. In heavy-use environment, good enough in the small parts usually means won't last. It's the hidden details that keep in the whole machine together. Next time you are choosing gym equipment, pay close attention to how easy it is to assemble. If setup takes too long, that's a problem, especially when time means money. A better option: choose a supplier that pre-assemble their equipment for you. They only remove what's necessary for shipping. That means 90% of the work is already done. So all you need to do is reconnect the parts and you are good to go. Ever started a rep and felt like nothing's happening until the weight suddenly hits? That's called a dead zone, and it breaks rhythm, control, and client trust. And here's the thing, It's not a strength issue, it's a design issue. Specifically, the cane. Watch how the first few degrees have no resistance, then suddenly it kicks in. The cane is what shapes the resistance throughout your movement, and the smart cane matches how your body naturally produces force. Take a look here. This cane isn't round, it's shaped to track your strength curve. Muscles don't generate equal force across the whole range of motion. So a circular cane, it doesn't match. It creates gaps, stalls, or spikes. But when the cane follows the strength curve, resistance rises and falls with the body's capacity. The result, no jerks, no stalling points, just a smooth, consistent resistance, start to finish. That's what makes a machine feel natural, because performance isn't just about strength, it's about how strength connects with motion. Ever select a weight but felt it didn't quite match the effort? That often comes down to Pulley ratio, how force transfers through the system. Most machines use a 1-to-1 ratio. Selecting 50 kilograms means pulling 50 kilograms. But if the pulley setup uses a 2-to-1 ratio, the experience changes. For example, when you select 20 kilograms on the stack, you are actually pulling 10 kilograms of resistance. Let's look at this example. Stack set to 20 kilograms. Pulling force measured about 10 kilograms. That's how the ratio affects the output. This design smooths out the motion, which can be useful in long-range or single-joint exercises while finer control is needed. It also means the machine doesn't require an oversized weight stack to deliver effective resistance, which can lead to a more compact layout overall. So, while pulley ratio doesn't change the machine's total strength, it changes how the user interacts with it from rep 1. Adjustability is one of the most used and most overlooked aspects of gym equipment. When setup is slow or inconsistent, it interrupts the training flow and creates user frustration. In well-executed designs, the seat and the backrest adjust simultaneously through a linked mechanism. This reduces setup time and helps maintain proper posture without trial and error. When systems rely on independent adjustments, users often encounter misalignment, repeat adjustments, or inefficient positions. This leads to lost time and inconsistent training posture. Linked systems with wide adjustment ranges allow machines to accommodate users of various heights and proportions. This ensures that the handle, seat, and support points align consistently, regardless of the user's size or experience level. Designing for adjustment efficiency isn't just about convenience, it's about repeatable ergonomics that support training quality across diverse user groups. Cable slack is one of the clearest signs of poor tension design. You will feel it the moment you start to pull. A short pause with no resistance. Try this. Pull the handle gently from rest. If the cable sags or shifts before tension builds, that's slack in the system, and it breaks the connection with the load. On systems with built-in pre-tension, the cable maintains light, consistent tension, even when idle. So, resistance engages immediately with no delay. Watch closely during a forward motion. There's no bounce, no catch-up, no early dead zone, just a direct resistance from the very start and through the full range. This effect depends on two factors: precise cable routing and mechanical preload systems. These components keep the cable aligned, reduce slack buildup, and help maintain consistent output over time. You won't always see these design elements, but at the moment you move, you will notice whether they are there. Okay, you forgot a tight cable, smooth movement, but here's the next question. How many people can actually use it? How many training angles can it support? Good machines aren't just strong, they are flexible. A single piece should serve more than one purpose. On a versatile machine, one station supports multiple motions. Adjusting the backrest or seat angle can shift the focus. For example, from a chest press to a shoulder press, without needing a second setup. Well-designed handles offer multiple grip positions, horizontal, vertical, or angled, to support variations in technique, comfort, or muscle focus. To fit a wide range of users, adjustable seat height, back support, and foot placement help align the machine to different body sizes, improving comfort, safety, and performance. This kind of flexibility improves space efficiency and allows more users to trim effectively using fewer machines. Versatility isn't just about saving space, it's about maximizing access and utility in real gym settings. Alright, adjustability is great, but the flexibility only works if the equipment actually fits the full range of users. And that's where a lot of machines fall short. Some machines work fine if the user happens to be right around average height. But what if someone's 1.50 m or 2 m 10? Well-designed machines account for user height variation from the start. Seat height, foot plate position, and handle reach should all be adjustable, without extra blocks, props, or manual modifications. A wide and precise adjustment range helps users enter the correct position quickly and independently. This improves alignment and reduces strain, especially in multi-user for high turnover training environments. When users of different size can achieve the same posture and movement mechanics on the same equipment, it shows that the design accommodates real-world diversity. That's not a premium free feature, that's a baseline for safe, consistent training in any commercial setting. See, a good machine isn't just about one strong part. It's how the frame, the pulleys, the seats, the adjustments all work together. Because most equipment doesn't fail all at once. It starts with small things, a loose bolt, a slight wobble, a stretched cable. And over time, those small issues lead to complaints, downtime, and higher long-term costs. That's why build quality matters. Not just for safety, not just for appearance, but because every part affects trust, and trust is what keeps your gym running. So if you are comparing equipment for your space, for your team, or your clients, look past the surface, check the structure, understand how it's built. Because in commercial gyms, good design doesn't just last longer, it moves better, feels better, and supports better training every day. Now you have seen what to look for when choosing commercial gym equipment that's built to last. Got questions or something specific you want to know more about? Drop a comment or visit our site to keep exploring.